We'll now consider the minimum triangulation problem. The input to the minimum triangulation problem consists of n points v1 through vn, which are vertices of a convex polyhedron, convex polygon in the plane. So, for instance, the vertices 1, 2, 3, 4, 5, 6 in this hexagon are an example of an input. And the goal is to find the minimum cost triangulation of the polygon. Specifically, we want to subdivide the polygon into triangles which is known as a triangulation. We want to triangulate the polygon in a way that minimizes the total perimeter of all the triangles. So in this example, we could triangulate this polygon 1 through 6 in as follows. We could, for instance, divide the polygon into triangles this way, or we could divide it this way, or for example you could do this way, or many other ways. Each way of dividing the polygon into triangles has a cost associated with it, which is the total length of all the edges in all the triangles. So for example, the cost of this triangulation is equal to the perimeter of 4 triangles there, which is it's triangle 1, 2, 6 plus triangle 2, 3, 4 plus triangle 4, 5, 6 plus triangle 2, 6, 4. And what is the cost of each of the triangle? It's the length of the edges of the triangle. So for example, the cost of triangle 1 to 6 is the length of edge 1, 2, which I'll call by L12 plus L26 plus L16. So let's assume that we can calculate the length of any edge of the polygon efficiently. If you know the coordinates of the two endpoints, it's an order 1 time computation to compute the length of an edge. Given any triangulation, we just want to add up the lengths of all the edges of every triangle, and then that gives us the cost of the triangulation. And what we want is, among all possible triangulations, the triangulation with the smallest possible cost. Now we'll come up with an algorithm based on dynamic programming for this problem. Like any dynamic programming algorithm design, we'll have to first come up with a subproblem, write a recurrence relation, and then solve the subproblems in a particular order.